Hi, my name is Wenruixin. This is my object-oriented programming project called Space Cloning. This is an Android application built in Java in Android Studio. In this app, the user manages a space cloning crew. The user can recruit crew members, move them between different locations, train them, and send them on cooperative missions against generated threats. This repository is public on GitHub, and it contains the full Android Studio project, the documentation, the UML diagram, and the submission tasks. The project follows the core theme closely. It includes the required features such as crew management, training, missions, recovery, and data structures. It also includes several bonus features, such as recycler view, tactical combat, larger squads, statistics, fragments, save and load, and a custom memorial system. Here I show the documentation folder. It contains the project documentation, the UML class diagram, and the Moodle submission tasks. The documentation explains the project idea, implementation, application flow, installation steps, tools used, team composition, and the list of implemented bonus features. This is the UML class diagram of the core logic. It shows the main classes and their relationships. The design is based on object-oriented programming. Now I will briefly show the code structure. This is main activity Java. It is the main entry point of the app. It holds the fragments and controls navigation between screens. Now this is the crew member Java. It is the abstract base class for the crew members. The different roles such as pilot, energy, medic, scientist, and soldier are implemented as subclasses. This shows inheritance and polymorphism. This is the cloning storage Java. It stores the crew members and cloning data. It uses a hash map to store crew members by ID, and it also handles saving and loading. This is Mission Energy Java. It runs the turn-based mission logic. It generates the threat, applies player actions, handles retaliation, and creates the mission log. Now I will show the home fragment and crew list fragment. These fragment classes are used for the user interface. The app uses a single activity with multiple fragments, which is one of the implemented bonus features. Now I will run the application and demonstrate the main features. First, I receive the data to start from a clean state. This is the home screen. It gives a summary of the cloning. Here we can see how many crew members are in quarters, simulator, mission control, and medbay. From this screen, I can open all main parts of the app. I can also save data, load data, or receive the cloning. Now I will recruit 3 crew members. First, I quote Nova, a pilot. Next, I quote Rex, a soldier. And finally, I quote Mara, an engineer. Each specialization has different bases, so the player can build different teams. Now the recruited crew members appear in quarters. Here I can see their names, specialization, current location, states, energy, and morale. This list implemented with recycler view. The different specializations are also shown with different icons. From quarters, I can move the selected crew members to the simulator for training. Now I'm showing the simulator screen. Training increases experience and experience improves skill power. In this project, training also improves morale. Now I train the selected crew members. We can see that experience and training costs increase. After that, I return them to quarters. When they return to quarters, their energy is restored, but their progress remains. Now I demonstrate the save features. The app creates a manual save file in JSON format. This is part of the data storage and loading bonus features. You can see I have moved the crew to mission control. Here I can prepare a cooperative mission. The player can select 2 or 3 crew members, so this project supports larger squads. For each selected crew member, I can choose a tactical action, attack, defend, or special. This demonstrates the tactical combat bonus feature. The panel above also shows a commander recommendation and moral information, which is part of my custom feature. Now I launch the mission. A threat is generated automatically, and it stays cycle with mission progress. The mission is turn-based. Crew members act one by one, and the threat retaliates after each action. The result area shows the threat energy bar, the final crew energy bars, the mission summary, and the full tactical log. This demonstrates mission visualization, randomness, and turn-based mission system. Also, different specializations can get bonuses against matching threat types. This is the statistics screen. It shows colony-wide statistics, such as total missions, successful missions, and failed missions. It also shows virtual progress bars for win rate, mission readiness, and average morale. Below that, the app shows per crew statistics. This demonstrates both the statistics features and statistics visualization. Finally, I demonstrate the load feature. First, I received cloning data. Now the overview is empty. Then I load the manual save file, and the saved crawl data comes back. This confirms that the file-based saving and loading works correctly. In conclusion, this project is a Java Android application that applies object-oriented programming to a space colony management game. It includes recruitment, training, turn-based missions, recovery, statistics, and file-based save and load. Thank you for watching my project demonstration.